welcome back to this tutorial. If you haven't watched the first part of this video, I really encourage you to go there and get yourself acquainted the technology of Alephium, a blockchain. So in this part, we want to work on developing on RAF. RAF is a programming language that is used to build smart contracts on the Alephium blockchain. It's pretty much similar to Solidity, with just some differences. So if you want to be part of this tutorial, please hit that like and subscribe button, smash the notification bell icon so that you won't miss anything coming here on this channel. Okay, so that is what we want to do in this particular tutorial. I'm going to teach you how you build a simple smart contract, and then compare it with Ethereum so you know the differences, and we'll also test it out so that you can see how it works on the chain. So if you're ready, let's jump into the tutorial. So guys, this is Alephium's landing page. Okay, this is their website. You have all the information that you need to know about Alephium is right here. Okay, so I'm not going to go through all of them right now. I just want to get you to the most important part, which is the documentation. Why is it most important? Is for you as a builder, because you're a builder and not just a regular user. So you come to build a Dapp, it takes you to the documentation of Alephium. See, if you want to build something on the Alephium blockchain, I would really recommend that you use a documentation to learn about it. Join the Discord channel for Alephium. I'm going to drop a link in the description section below so you can easily join their Discord channel and ask questions where necessary. Remember, if you're good with Solidity, this shouldn't be such a big deal for you. All right, so this kind of gives you an overall of everything that you need to know about Alephium, blockchain. But what we want to focus on is this, RAF programming language, okay, which is the language of the Alephium blockchain network, for building smart contracts and so on. Okay, so there is instruction for types, all manner of types, struct, function, contract, operators, how you can manipulate this, and also built-in functions. So there is a lot of that, and okay, so there's a lot of that you can consider doing. So, but for this tutorial, I want to run this on an environment. You're going to need a couple of things. First of all, we're going to need Docker. Okay, you need Docker for running their blockchain. It doesn't have like an online blockchain for DevNet. You understand? For development purposes, you can run your own node on your computer by just using this Docker experience. It's a lot easier to use Docker, which is really cool. So I would really encourage you to use Docker in this session. I'm just going to take you through it. But if you don't have Docker, I have a platform which you can use to do this with me. So I normally use Gitpod workspaces. So I'm going to use this Gitpod workspace right now so that anyone, whether you have Docker installed on your computer or you don't, you can have access to this. So I'm going to use a repository I called empty. It's just an empty repository where I install, it's just an empty repository so I can run codes on it. Okay, I'm going to make sure that I'm launching from my, VS Code. You can also use browser in case anyone that you prefer, but I would recommend you use the desktop version. And you should already have VS Code installed on your local machine. So you click on continue, and we're going to wait for it to complete. Okay, so now there are some things you need to understand. You see this is open now, is ready. I can launch it on my VS Code. So while that is launching, there are some things that you have to get installed. The only reason why I'm doing this with Gitpod because it has all the necessary things that we need installed. It has Node.js installed and all that. So I'm going to expand this, and let me come to this documentation. Yes, trust this browser. Come here. So let's come here. So I'm going to come to this overview. See, build a Dapp, tutorials, quick startup. Now look at this. You need the codes for this particular development is going to be written in TypeScript. So we're going to be combining TypeScript and Raft programming language. Raft for smart contract, TypeScript for testing out this smart contract. It's quite important that you understand that we're using TypeScript here. We're not using regular JavaScript, okay? And the next thing you want is to make sure that you have a terminal. Everyone does that, have that. Node.js, it has to be greater than or equal to 16 and NPM version. All of this you won't need much. It's not a no-brainer. If you're already in the JavaScript space, this should be easy for you to understand that is a requisite. So next thing you want to do is to create a new Dapp project, okay? They already have you can call this, I think you can call this whatever you want. You can see create a new directory, call this an initialize sample project. Okay, so let's initialize a project here. So I'm going to copy this line of code and come to my VS Code. Yep, I'm just going to open this terminal. See, this is being run on VS Code. Right here inside this empty directory, I want to paste this code. Okay, it's called npx at Alephium/CLI. You want to invoke the latest Alephium CLI control to initialize a project that is named Alephium tutorial. You can call it whatever you want, and then I'm going to click OK, and it will ask me, this will include you installing this particular version, which is the idea. So by running that, it's going to pull all the packages and have this whole project set up for me here. So it has initialized the project. You can see here, this is a directory that has all the information that you need about this project. Okay, so that is cool. And this is where you code. This is where you write all your code and all that. We've been able to set up that correctly. But there's also one step more. We need to set up the development server. Unlike Ethereum that uses Hackathon, Foundry or Ganache to run as a server, you don't need I'm going to increase this a little bit, okay? So it will be a lot visible. All right. So for Alephium, you use their server, you run your own node, and how you run your own node, which is basically localhost. How you do that is to come here. The prerequisites, you want to make sure that you have Docker and Docker Compose installed. I have it installed on my machine. I have Docker, but since you're going to be using, what's it called? You may not have Docker installed on your computer and you still want to follow this tutorial. I'm using this Git podmin so that it will be generic for everyone. So that's why I'm doing this, okay? So let's come back here. You want to come to this Alephium stack. You want to get it. I'm going to visit that endpoint. Boom. Okay, so I'm going to clone the entire repository, the entire stack. With this repository, I could run the Devnet mainnet or testnet. So I'm just going to copy this, come back here. Okay, so this is Alephium stack right here. So I'm going to copy that, come to my VS Code, and I'll just do git clone and paste this. So to install the Alephium, stack. What you can also do is you can give it a different name, like you can call it server or node, anyone. So for the sake of this tutorial, we're just going to leave it like that. So it has cloned it. You can see Alephium stack right here. And the cool thing is when you open this DevNet, you can see that there is this Docker Compose script that is responsible for launching this project, the service, the blockchain service, okay? So you can go through all this on your own time, but among all these ports, there is port different this is the port for, all these ports are for DevNet, okay? So this is DevNet. So I can come here, I will have to launch this. The cool thing that I'm saying is I already have Docker, -- version installed here. You can see that. So I have Docker and Docker Compose. I think, let's see. You see, I also have Docker Compose installed and Docker installed by default. Okay. And if you actually have this desktop, Docker desktop, okay, it have those two things installed by default as well. So you'll be on the same page with me if you're deciding to run this on your own local machine. All right, so what I need to do is I could run, say, Docker Compose up, and this enables me because this extension called Docker here, this Docker extension, will enable you to run this process, to just provide some, handy commands, you understand, options that you can use to quickly start up service or any one of the service. So I'm going to say compose up so that it will run this blockchain server. You see, I didn't need to do anything, much. You see, this is being pulled from the blockchain. From Git, from the various images where they are on Docker. So it's being pulled and it's going to be done. And once it's done, you can move. The cool thing is that this whole package contains both the Explorer, you understand, like you can have an Explorer, which is cool. I don't often have that with other blockchain, nodes such as, what's it called? Hardhat doesn't have, you can't just come and do, you can have access to a front-end Explorer for you to be seeing the transaction and all of that, that you do. Okay, but you can do that with this, which is great, and a whole lot of other services that are part of this backend. So this is running. Let's just wait for it. Okay, so this is started. If I come here, you find out that just about all the services are available except this one. I don't know why this front end, this Devnet Explorer front end is actually having issue. I think it's because there is a certain port that is using exactly what it's supposed to be using. Maybe that's why. I don't know, but I haven't had success launching that File Explorer angle. So that is up and running. Okay, and close here and come to come to the tutorial. This is the project structure. It's almost similar to what's it called? Hardhat, the way we have our Hardhat structure, our project structure organized. You can see this SRC. This is just contract based, but you also have a provision. If you want to make this a React project, there is no problem. If you want to make this a Next.js project, you can also configure all that within this. All you need is to work on this package.json and add the full packages and correctly put them together. But you should also know that there is a specific package. If you come to this overview, you can see build a Dapp, and you can see this one called Dapp with Next.js, okay? And you can run this script here, and you install Next.js based project all set up together for you, which is pretty cool in my opinion, All right, so coming back to explain this, not here. Coming back to explain this. This folder, you should know, be aware of this folder. This folder here, this is called contract folder. This is where you put all your smart contracts that you write. And these things are written in RAF programming language, okay? And I've gone ahead and installed an extension called RAF. Say RAF. Okay, see RAF VS Code. Okay, this has been installed already. And this helps me to do some things like syntax highlighting and all that. So I would recommend that you have this installed, and it's going to be pretty cool for you. But you can also try these other ones. I don't know how usable they are. Okay. So yeah, I've not checked it out, but this one here, this RAF VS Code, okay, this is the one that I will recommend for you, RAF VS Code. So have it installed, and it will just work just fine for you by highlighting all the things that you need. So this is how a Raft smart contract is. Just like with Solidity, you can have this thing called contract, name of the contract, and some startups, startup, what's it called? Startup parameters, or arguments, okay? But in Solidity, this would have been passed into the constructor function. So there are just some things we're going to do that. You can see how, event is also available here. You can see enum is available here. It's also available in Solidity, and this is just a simple token contract, okay? And we're going to go through it in depth in the subsequent part of this video. So this is for contract, this is for script. This script helps you to do stuff like deployment or any other interactive activities that you want to communicate with the smart contract. And this is the source here. This is beyond the scope of what we want to talk about right now. Let's leave that part alone. And this test is a test script that you can use to write some tests, on your project, okay? So there are some commands. This Alephium package, this is where it has definition for information concerning this project, okay? So for example, we have endpoint for Devnet, endpoint for testnet, endpoint for mainnet. You have a definition of the project, the Alephium project, okay? So that's why it's called alephium.config, .ts. So it's a configuration for Alephium, all right, for the entire project. And I think at this point, we are good to go. Okay, I just want to show you this package.json and a few commands that we can look at. Look at this build command. This is for building the project. And, all these commands are going to be useful, but the one I want to show you here is this compile. It is used for compiling your smart contract, because when you compile your smart contract, it is used to, to check your smart contract. If there is any error, it will pop up, and then you can correct all those information on, on your code before you can deploy. Okay, so you compile first before you deploy, and we have deploy script. This particular command is used for deploying the smart contract to your DevNet that is currently running right now. Because if I come here, reduce this, and let's go to expose port. There's so many ports here, but one of those ports here is for the DevNet. So yeah, for now, let's leave it alone. But you can use this to deploy a smart contract into the network. That is just what you need. These two commands for this scope of this teaching: compile and deploy. That is what you need to know. Okay. As with that said, I will then take you through the development process in the next part of this tutorial. So the first thing I want to have you do is, let's come back here. I'm going to go to this location. This is a smart contract written in Solidity, and we would like to translate this contract to Raft. Okay, so that's the idea that we're trying to accomplish here. So at this point, I would like to test it out to see if everything works out well. So we can go to Remix ID. I've already checked this out. So go to Remix ID. It's an online ID for testing our Solidity code. So since this code is Solidity based, I just want to show you, that it's working and everything is compiling and all that. Okay, so this is the smart contract right here. Okay, we can test it by clicking Control Save. You can see this is compiled. There's no error in it. I compile it again, showing green check mark. Then we can deploy this. You can see it's deployed. Look at the contract right here. It gives you access to just about 2 functions. This mapping isn't really what we want. So this function called deposit to user. That one is to get donors total. Okay, so I could put an address which I want to deposit some money into. So I would say, let's copy this address. Then I paste that. I want to deposit like As of this time, if I copy, you can see if I check this, you can see that I have 2 ethers here, and if I check a different account, I should get nothing out of it. So click that, you can see. So this contract works just fine. And this is the contract we're trying to translate into RAF programming language. So I will have to copy this, or just go to my RAF, to my IDE. So come here, and at the root of this folder, I'll create a new file, call it donations.sol for Solidity, and just paste this in. No, not that. Let me copy the entire script. Come here, paste that. So this is the Solidity code. Now let's come to this place. I don't want all these contracts. These are the default ones that came with this project, so I'm going to remove them. I will remove these ones. Delete. Yeah, delete them. So I'm also going to delete these tests. And this script here, I'm also going to delete it for now. Yeah, I'm going to delete it for now. So I don't have, this is also like starting from the scratch, okay? So there's nothing new here. Everything is just from the scratch. So at this point, I'm going to create a new file. I'll call it donations.raw. RAW is a short form for RAF, okay? So here we go. Now let me shift this over here. No, here. Right, and bold this. So at this point, we are going to start translating this code into RAF programming. That is what we want to do in this particular section. So to do that, you start with a keyword called contract. Okay, so this is a contract, a keyword called contract, and then you can give it the name. The name of the contract is going to be called donations. Okay, and in RAF you have to wrap it with a parenthesis. Unlike in Solidity, you don't have to wrap it with parentheses. These are some simple things you just need to understand the difference between Solidity and RAF. So in RAF, we also have this concept called mapping. Okay, so if I copy this and paste this here, it's almost equal to how it is done in RAF, but I have to remove this public, and I have to make sure that this is a square bracket and not a curly brace. And the concept of address, remember, mapping is a data type, right? Even in Solidity and even in RAF. Address is a data type in Solidity. In RAF, yes, as well, but you have to address it with a capital, A, not small letter. And unsigned integer in Solidity, you have unsigned integer 256. You have that. You have something like this, in Solidity, and it's a valid data type. But how you do it in RAF is a shortened form of it. What just U256. Simple like that. And you don't end. In RAF, it's not essential for you to put a semicolon at the back of your code. You can try that. I've not tried that, but the logic is to just leave it without a semicolon, okay? And then you need an event. You can see now I'm going to translate this event. How is it written in RAF? Let's have it here. This is how it's written in RAF. Almost word to word, but let's modify it. Event, and then the name of the event, which is donation. Instead of having, you understand, you have to put in a key value kind of format like this. So this is the donor, and this is, you do the same here. Sorry. Recipient, okay, is also an address, and then the amount, okay, is this unsigned integer 256. So this is how you specify what's it called, an event in RAF programming. You see, it's very similar to how smart contracts are coded in Solidity. Moving forward, we want to specify an enum. In Solidity, if you've been watching a lot of my videos, you find out that Solidity also have enum, the concept of enum. So the concept of enum is basically having an enumerable. If it was in Solidity, I would write something like enum, okay, and give it the name of the enum. Say I'll say error code, okay, and in this error code we have not found. Let's say not found, okay, and you have something like unauthorized, missing, etc. You have a concept like this in Solidity, but if you want to do this sort of thing in RAV, you can do it exactly like this. So for example, you have to say not found. This thing now, if it was in Solidity, you can do something like this. I mean, if it was in Solidity, something like this will equal to something like this, okay? And this will also equal to something like this. But since we're using RAV, this is how RAV specifies its own enumerables, okay? So you have to assign a value to it, while in Solidity, I don't need to assign anything, it just goes straight forward, okay? So those are just some differences that I'm pointing out for you now. And afterward, okay, you're saying insufficient amount, that is the only error code that we're going to need in this particular build. Now, you want to create a function. The function is created by this public, or you can just leave it like this if you want it to be private. So one public function, you can specify the argument, and then this is how the function is created, and then you can return whatever you want to return at the end of the day. So for this, I will need, I want to call this function deposit, just like we have here. I'm going to call this function here deposit to user, and this argument of one recipient, I'm going to have, and in Solidity, I actually did use msg.sender to extract the amount of money that is, being sent along the transaction. But in RAV, it has a different method of implementing it. So you have to use this way. We say recipient, okay, is an address. Okay. I also need an amount, which is, this data type. So you need that. And you see this require function where we're saying require that, okay, this thing is greater than this. In RAV, how you do it is by saying assert, okay, and the pound symbol. So we're saying assert, we're saying that this amount must be greater than 0. Otherwise, it should invoke the error code, call on the insufficient amount. So this should be the error code that will be reverted in case it's less than 0, the amount that is trying to be deposited. So now the next thing you should understand is in Solidity, we have the concept of msg.sender, which gives you the information about the current person making this transaction, okay, or calling this function. So how you do that? You can use let. Let is used to define variables in RAV programming language. Unlike with Solidity, I think you can just write it straightforward, okay? So you can define it with any one of those variable types, okay? That's how you do it in Solidity. But in RAV, you say let, and let's call this caller. So this is the one making this request. See, and this is the function that is responsible for having this, say, caller address, okay, and pound symbol like that. This is cool. Okay, I know that Solidity is pretty old. It's pretty older than this guy, Raf here, and this language is still on development, and there's a lot of things that if you want to compare this to this guy, it doesn't just, there's some things that is maybe still lacking, but the environment that this guy exists is way better than the environment that Solidity exists. And if you look at it, this guy is pretty straightforward and, simple, as long as much as Solidity. You don't even need to specify all these things, but Solidity does specify all that. Okay, so I'm just giving you some of the differences, and you can see how simpler it is. It is to code with RAF. You understand? So there we have it. We have access to this caller of this function. That is the same thing as msg.sender in Solidity. So the next thing now, we want to do something like this. Okay, that is to assign the amount of money that is being sent along with that transaction to the recipient that we want to deposit that amount of money to. But in RAF, you have a way of doing that, because if I try to do something like this straightforward, let's say something like this, I have to access. So let's try it. So we have this thing, let's say donors, which is this, right? And then you pass in the recipient, and you say MSG, what is it called, 4 plus equal to, and then you say, you can use this operation right here. You have to assign the amount of money. We don't have msg.send value. That is the problem that I do honestly consider about the transaction sequence. Okay, so it's okay if they are not following the exact format Solidity follows in carrying the value or the amount of money along with the transaction in that format. So, but how you do this is why we now have this amount. That is why we're passing this amount here. So we use this to record that. Meanwhile, we will have to ensure that it's on the end of the other developer to ensure that money is actually paid first before this function, is fired. Okay, so we have something like this. And for me to do that plus equal to this amount, I can't do it that way. I have to do it this way by accessing this, adding it with this amount before I, update this. This alone will produce an error, because what if this recipient don't yet exist? Okay, so in RAF, if a recipient doesn't yet exist in a mapping, there's a way you create that. You create it so that, it can work out. Okay, so you have to first insert it. So, and all of these things that I'm stating are already here in the RAF documentation. If I come to mapping, maps, these types, and you can see that there is an insert method for you to put in values, and you can access values this way. Okay, so you can also remove values. So these are and you can also check if it contains. So those are the method that a map does come with. So we want to first check if it exists. So we can say if, this is how you write a conditional statement in RAF, okay? So you want to say if this donors, okay, dot contains, okay, make sure you put this pound symbol. This is how methods are addressed in RAF. Okay, so if this donors mapping right here contains this recipient, then this is what you want to do. You want to just update the record, because at this point, it actually does have a recipient in this particular recipient in this mapping already. So you just need to update it with the new value. Otherwise, if this is not so, it's almost like the way an if-else statement in JavaScript is, so it's pretty simple. If this is not true, then we want to do donors, let's say donors dot insert. There's a function called insert, which enables you to add new values, inside a mapping. So I'm going to insert, and the insert method takes 3 parameters, even though we're actually working with 2 parameters. And that is one confusing thing I initially felt with the RAF programming language. Like, I didn't see any reason why the caller or whomever is making the call should be included in what you add in the mapping. I may be wrong, but you have to pass in a caller here, which is the person that is making this transaction, and the amount of money, the person that you want to send this to, which is the address, which is, and actually the reason why I have this address here is for this guy and not for this guy, okay? And then for this place, the value here, you then have to put in this amount. Okay, so you're inserting it if this is happening for the first time. So this is a little bit of a difference between how Solidity is going to approach this information versus how RAF will approach it right here. And lastly, for this emitting of donation, so we can do something similar here, or we have to do it in RAF's way. So you emit donation, and who is the donor? The donor is the caller, and who is the recipient? The recipient is this guy, and what amount? The amount is whatever amount that was passed in here. Okay, so at this point you're done with this particular function, and then it will remain one last function for us to create. And this last function is, you come here to replicate it. We're going to say public function. All right, so I'm going to call this function get total donors. So come here. This is just a get function. Okay, it doesn't require much. I will need the donor, so I can do something like this. Okay, so this will be the donor. Okay, so we need access to the donor. Whom do you want to check their balance? Okay, so I'm going to pass in the address here. The address is going to be passed in here. And for this, you can specify the data type that you are expecting to return. So if we are accessing this mapping, we expect that this data type should be what should be returned. So you can pass that in here. So this is the data type that is to be returned. And you really don't need this place anymore. Okay, except you are not expecting anything to be returned, but this is exactly what we're returning. So at this point, it's very simple. You need to just copy this line of code, paste it here, and do these changes with me. So the change that I want to return, if this does exist, let me make sure that I remove this. Okay, if there is a donor, okay, if these donors contain this particular donor, then it should return that donor. Otherwise, it should just return 0. Okay, 0. That will represent that there is no value like this. Instead of returning an error, it should just return a 0. So if that particular donor has not been in donation on this smart contract. So this is just like a crowdfunding / a donation, smart contract. In the next part of this, we're going to be compiling and testing out this smart contract to show you how it works. Okay, so let's do a short comparison, and see how this turned out. We have about 31 lines of code here, and we have about 23 lines of code. Solidity seems to be very shorter, for executing a simple smart contract such as this, and this seems to be a little bit longer. But the syntax are quite similar with each other, and there are some things that are quite redundant in Solidity, such that you have to always be putting it in every smart contract that you write. So such as these two items, they are not necessary that I should be putting them in every single smart contract that I write. It's not supposed to be so, in my opinion. But for a simple smart contract like this, Solidity just have a simpler approach to it. At the same time, this is so much very powerful, and it kind of shortens a lot of things, and I just like them both. That's just what I would say. They are simple to both write. I mean, if you think that this is any one of this is complex, you should try Rust. Rust is just very rusty. Okay, so this is just bread and butter, you understand, if you ask me. So we have been able to fulfill that. So that is it. Now let's move on to testing, doing some testing and deployment. But before you move that, you want to check if there is any error in this script, and to do that, we'll have to navigate to this folder. So we say cd Alephium tutorial, and in that I could use yarn on npm. So let's use yarn, or let's say npm run compile, and then you run that script. So it's failing. Okay, let me also run it with yarn. Say yarn compile. Let's see what's going on. So it's saying loading Alephium config, error when checking if network is live. So because the network, the devnet is not live, I kind of turned it off before. So I'm gonna, bring it up back by running a devnet, So you need devnet to be able to compile a smart contract here. So I'm gonna, bring that back. So we're running this command. Basically, that simple command that I did, it's gonna launch this devnet. Okay, so this has, been executed, and it's totally running. It's online. So let's run that compilation again. Yarn compile. Okay, so now there is a problem here. So the problem is complaining about this syntax. There is a syntax error in this mapping. You see, this is a Solidity style of, indicating a relationship between address and unsigned integers. So how you do that in RAV is by using a comma. So let's save that and compile this again. Okay, so we have another place here where we have line 26. If I come here, line 26, you have donors and donor. So there need to be a return statement here. You can see here it's saying compile error, and it didn't quite return expected a statement. Okay, now this also have to be a lot simpler. The error reporting need to upgrade with this RAV programming as well, so I will know exactly what is wrong with this. Okay, so I'm also going to try out some semicolons to see if it does affect the functionality of it. So I'm going to run that again. So let me remove them and see if it changes anything. So I'm going to save that. Compile. Okay, so obviously you shouldn't be using semicolon. So here is saying public function fail to compile, so now I need to review some things concerning update functions that changes the state of variables on the smart contract. There is something you need to know concerning annotations in the RAV programming language. If it was Solidity, you would not need to add any other thing, but some features of the smart contract need to be enabled using annotations. And let me look at annotations. So built-in function, or you can just search for it here, say annotations. Okay, so this is annotation in RAV, and the one that is currently supported is just this using annotation, and you have to specify this, pre-approved asset, true or false, whether the function uses user pre-approved asset, the default is false for contract, true for script. So they're just these annotations, they are necessary for making changes, on the smart contract. You understand, when the code runs and the code wants to make some changes on the state of variables, you have to enable some of these annotations. Like you can see from on that we made change to this place and made change here. So those two things kind of require that annotations are added to it. So the annotations we're going to need is this one called pre-approved assets. So I'm going to copy this line and add it here and at the top of this function. So save that. Okay, so and then you run that line again, compile, and okay, it's no longer giving that specific warning. Now it's not talking about check caller. This check caller is another annotation that needs to be added. So no external caller check for function, donations.deposit to user in the in the function, or its caller callees, or disable it with at using. So basically we need to add this one as well, this annotation, to make sure that it caters for this caller address function here. So I'm going to add that and disable it so that it will not give us that warning. So by the time I do that and compile again, okay, you can see all the contract codes are working just fine, and you have a check mark. Sometimes even in RAF programming, if you define something like a variable and never use it, then it's also we complain. So no variables are left unused. RAF programming doesn't allow that. All right, so here we go. Now the next step we want to do is to create a script. This script to help us to deploy this smart contract into the network, okay, and then do some basic checks, all right, to verify if our contract is working as we have already programmed it to be. So now we need to create a new file and call this, start with 0, deployment script in this RAF programming, or this RAF project. It should always start with that number, so 01, call it deploy, and then dash, call this donations .ts TypeScript. So at this point, I want to define a variable called deploy contract, okay, and it's going to have a type called deploy function, and it's coming from Alephium CLI, okay, and we want to also give it a settings that is coming from Alephium configuration, the Alephium configuration file here, which you can find here. So these settings here, so we're also adding it, this setting exported, we're also adding it to that type, we're also adding it to this definition here. And it's going to be a synchronous function. Okay, so now there are some things I'm going to need. I'm going to need the deployer. Okay, I'm going to give it a deployer type, deployer type, and it's still coming from Alephium CLI. I'm also going to give it network so that it can know exactly which network we're working with. So network is coming from Alephium CLI as well. The network is also going to have settings. Okay, at this point, we can come here. We want to define this as a promise. It returns a promise, void as a type of the promise. Okay, so the first thing I want to do, I want to define the issued token amount. This step is not really important, like that, but no, it's not really important, so I'm going to leave it out. So we want to say const result is equal to await this deployer right here, and then I want to call on the deploy contract function, and then Now, because there's this thing called artifact, each time that I do a compilation, yarn compile or npm run compile, it actually generates all these ABIs, all right? So this is like a Solidity equivalent of an ABI, okay? So I need to have that imported here. So for this contract, it's called donation, and it's coming from that artifact. And if the contract does have some parameters that need to be defined initially, so you can say initial fields, okay, and then you can list out all the initial fields or whatever. For our contract doesn't have any initial field, so we don't need to add that. We can just leave it empty. Okay, so then afterward, you can come here, and I want to log out some things. Okay, I want to log out the contract address, and there is also this thing called contract, contract ID, contract address. So I'm accessing this result. This is where deployment happens. Deployment happens here. I'm accessing the contract instance, which is the contract ID, and also getting the contract address. I'm just printing it out on the console. Okay, and after I print it out, so I can save this now. Let's run this to see first if it is working. And how you do that, you can do yarn, you say deploy. If you run that, no default deploy function. So now I need to make sure that I'm exporting this class or whatever this variable. I need to export it, otherwise it doesn't have access to it. It's just in this file. So let's export that. Okay, so deployment has happened, and you can see this is the contract ID and this is the contract address. Okay, just like with Ethereum, whenever you deploy a smart contract, it does have a contract address. This is the contract address for this specific smart contract that we just deployed. So there are some things that I still need to define. For example, I want to grab the signer. Signer this is a test node. I need an address. Before we deploy, we need a deployer, right? So the deployer is not going to come from thin air, but it's going to come from this test node wallet. So this test node wallet is used to get some dummy account that you can use for your testing. But you can also have it. They also have this thing, renode. If you're deploying with your wallet address, to the mainnet, it's going to have to take a little bit of a different shape. In this signer right here, it's going to be a different method. Okay, so for now, I'm going to import this test node from Alephium Web3 test. All right, and at this point, I have a node wallet, a couple of wallet addresses here. So then when I call this signer.get account, it returns me an array of addresses. All right, so I'm going to just pick one of those address. Okay, so I could pick address at 1 or address at 0. Okay, but if I actually just print out the address, if I say log, I say addresses. Okay, save that and redeploy this. Okay, you can see this dummy wallet address. In Ethereum, there is a different way of doing this, but if you have been following my classes, you'll be able to quickly understand how this thing works. Okay, so they have about 4 dummy wallet address that you can use for this purpose. Okay, so we're going to use just the first one. What next? We then need to define, like, you remember we have this function that takes in a deposit, the person that you want to deposit to. So it does require an amount, and the amount, let's say const amount is equal to, we want to send like 10 half tokens. All right, but you need to make sure that this is represented in a big int, and not just a regular integer. All right, so once you have that, can put that together, and then we then need to construct, or basically let's just try this first and then we'll come back. So this isn't yet needed, but we'll need it. Can comment it out for now, and we'll come here and say this const, want to create a variable called contract, and this contract is going to be this result dot contract instance. So this is the smart contract, right? And we want to grab this, say get. We basically want to use exactly the same name. You understand that? So I'm going to say this get donor total. So to get the total number of Alephium tokens this particular user does have. So I'm going to call on this await and say contract. Now, if you want to view, if it's a view, in Solidity, if a contract is if a function is just a viewable function, you have to write it directly, by saying views returns. You understand? And I think we can look at it from here. You can see where we have views returns. You understand? Because this is just a viewable function. It doesn't change anything on the blockchain. But this that changes something on the blockchain is not going to be view returns based. So, but in Alephium, it works a little bit different. So how do we deal with this? In Alephium, if you want to view a function that returns value, then you want to click on this, look at this view here. We have views and we have transact. Transact is if you're calling the function that you have to send in some data to modify the state of the blockchain. But if it doesn't modify anything but just read data, this is for writing data and this is for reading data. So I want to read data. So okay, dot view, and then you call this get donor total. And at this point, you can then pass in the value. Now you may want to say expected one argument but got 0. You may just want to pass in a number here, an address here, but that doesn't just work out fine. So Alephium does have a way of packaging the argument that you put in here. It has to follow the type definition that you see here. This type definition of donation types dot call method, and all that, call method param. So let me just show you how it is done. You say const, let's say params is equal to this thing called call contract, say params. This call contract params is coming from Alephium Web3. So we don't yet have it. So I'm going to say import this from Alephium Web3. So I've imported that. So this type is not available. Then after I've imported this, I will constrain it to this, because if you look, this has this is the donor and address. So we need to specify this in this format. That we have donor, and donor is to a string, because in JavaScript, address can be represented very well with a string. So I'm gonna say is equal to, okay, so then we'll now have to supply this args, short form for argument, okay, args, and is that arg here. You say this donor, okay, is gonna be this address here, right? So say address dot address. So now I'm making a mistake here, so I'm going to come here and just define it like this. So all right, so this param is not available, and then I can pass this param here, right? You see that error is gone. So you're passing this entire thing inside here. This is just a data type. You're just defining it properly. I don't know why it had to be a little bit this complicated. It would have just been a lot simpler, would have been very much better. But I know that the guys at Alephium, they are really doing such a fantastic job, and the network is growing, and Ethereum and its armies of layer 2 have been around for a long time now. So now we have this get donor total. We can then log off this information. So first of all, I want to log off, log console.log, / and then console.log address. So you actually are logging off this address that you're trying to top up some value in. All right. So, and then we can then say, before we even, because we want to check the state of the smart contract before and after we had made some donation. So for this account, we'll say contract balance before. Okay, and we can specify that. So now what is the balance here? We want to call this get donor and then say dot returns. Okay, this dot returns will return the value, but the value is in big int, so you need to convert it to number so that it will make sense. So I'm going to wrap this around a number. All right, so that to be an integer. All right, so if I save this and run this again, let's see that. You can see that this is the balance before. It's empty, doesn't have any balance. Great. Now I'm also going to duplicate this to have like balance after. So say balance after. Okay, so in between here, this is where we're going to run the operation of updating that particular, of making some donations. Okay, so let's make some donation. To make a donation, I want to call this await. We'll call the contract instance, and we say transact this time, not view, and you call on deposit user wallet. Remember, this function is to read from the blockchain. This is to write to the blockchain. And luckily for us, we don't need to have this method of specifying the argument in this one, so we can write it straight up here. This one we can also, I'm sure there's a way of also writing it straight up here. Let's see if we can just replace it here, which is cool, but then I have to do the same here. So in order not to do it multiple times, I think it's better to just do it once. Okay, so here we have it. And who is signing this contract? Who is going to be the caller? The caller is this guy here. Okay, who is going to be the caller? We want the caller to be this signer. I want to say signer. Okay, so the default signer, basically, that will be the caller. And then we say argument will be, if you look here, we have the argument here include a recipient and an amount. So I'm going to put that here. We'll say recipient. Okay, recipient is going to be this address. You know that we can just say addresses. Okay, let's just try this one now. Address.address. Okay, and all right, and also want to put an amount, but this amount don't yet exist because we've not enabled this. So when I enable that, we have this amount here. So amount is amount. And one more thing you want to add here is add to ALF. I think this has to do with the amount of ALF Alephium token that you're sending along in that transaction, because it has to be paid for. Here is not, you're not putting the real money here. This is where the real money will be, transferred from. So you're saying you want to multiply that, okay, this amount here, but you want to represent that in Alephium token, style. So 10, it doesn't just make sense, but you have to multiply it whether in Alephium token. So if it was in Ethereum, you would say 10 ETH, So we'll say 1 half. So you multiply it with this, and that will give you the value in Alephium, and then you make that call. And after you make that call, we can then check the balance after to verify if everything works. So let's go back to our code, redeploy this and run that again. You can see this is the address that we're working on, and you can see the contract before has 0, Alephium tokens, and then the afterward, it has 10, which is great. So if I change this to, let's say, something like 2, and for the address, I want to use the second address this time, and so I'm switching the address to another one. Now, when I run this again and deploy, you can see this particular address has only 2 tokens, and you can see that. So if I change that to the third one or the last one, so let's run that and let's increase the amount to, let's say, 5, deploy, again. And one thing you should know is, one thing I like about Alephium and how it is set up is that if you've already deployed a smart contract and there is no change, you didn't make any changes in the script, it's when during redeployment, it's not going to deploy a new one, it's going to retain that same address. So for example, look at this. There will be no redeployment of that smart contract because it is exactly the same, okay, but the rest of the scripts are going to run. So for example, you see that this ends with GUZ9, okay, so if I run that script again a second time, even though I change some things here by saying the second person here, say 3, okay, and then I run this without getting to even clear the screen so that you can see the address. You can see that it's the same contract that we're referencing here. We didn't redeploy anything, okay. Only if I make changes here. If I don't make any changes here, everything will work just exactly the same way. So this is just how you test, you test out your smart contract. This is a simplified format of doing so. Yeah. So hope that was quite expressive for you, and this is just the intro of it. I haven't shown you how to build a full Dapp, but that would be awesome to show you how to build a full Dapp on the Alephium network. And guys, there we have it for this particular tutorial, and I hope you actually enjoyed this smart contract development series. We can do more of this, okay. We are not only about being stuck in Solidity. There are other programming languages on the blockchain that you have to be acquainted with so that you can be stronger in the Web3 development spectrum. So you've seen the difference and the similarities between Alephium, RAV, and Ethereum Solidity. You've seen their syntax. It's not much different. It's just close, which makes it easier for you and me to easily jump in and build something together. So with that said, there is also an actual hackathon going on right now. It started on the 9th, which is today, 9th of September 2024, and it's going to last for 21 days. You can build something on the Alephium network. I'm going to drop a link, and I'm also going to drop a short video just to show you some things that you need to go through for you to be part of that development and build something and win something. There is winning of prizes up to $20,000. It's something that is going to be lucrative for you, so you should check it out. Check out the description section below to see the links that you can use in being a participant in this hackathon. So with that said, let's hit that like and subscribe button, smash that notification bell, okay, and watch this short video to just review some things that you need to see more about the hackathon. All right, I'm Dapp Gospel, and I'll see you in the next video.